Hello class, today we're going over the 2.6 notes for Algebra 2 on scatter plots and lines of best fit. We're going to start off by defining what a scatter plot is. So a scatter plot is a graph of a set of data pairs. And these data pairs are in the form x, y. So this is applied a lot in real life. Scatter plots show data for different things in our everyday life. There are different types of correlations of scatter plots. There's positive correlation, where you could roughly draw a line between them that goes up from left to right. A negative correlation, where they're clustered together in a way where you could make a line going down, so it falls from left to right. And then there's relatively no correlation, where they don't go in any specific direction. In this first example, we're going to describe the correlation of the data based upon what we just learned above. So in part A, if you notice, these are going in an upward trend. The data shows a positive correlation. That's what that means. If it's going up, it's positive. This means that as hours of studying increases, test scores increase. For part B, the points are clustered and going down. This means it's a negative correlation. And that as the hours of TV watched increases, test scores decrease. Now there's something known as a correlation coefficient. And a correlation coefficient is a number from -1 to 1 that measures how well a line fits a set of data pairs. So it means basically how well are those points clustered together. Okay, and -1 is where they're really clustered very well together, and it's a negative correlation. +1, they're clustered very close together with a positive correlation. Okay. So if it's -1, they're really tight and they're like this. 0 is where like they're everywhere, right? And then +1's where they're really tightly fit going upward. In this example, we're telling whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So looking at these points, I know it's a negative correlation, so it's going to be one of the negative values. And they're pretty close together. There's only a couple outliers here. Most of them would fit a line to data really well. So I would say it's closest to -1. Next, we're going to learn how to create a best fitting line, how we could put in a best fitting line for these problems. So for that, first of all, going over best fitting line, that's the line that lies as close as possible to all data points. So when you make this line, you want to make sure you have as many points above the line as you do below the line. Okay. So roughly the same number of points above the line as you have below it. To approximate this line, these are the directions for doing it. You first want to draw the scatter plot, so you're going to plot all those points of data. Then you'll sketch a line that looks like it follows closely to the data points. So there should be, like I said, as many points above as below the line. Then you're going to choose 2 points on that line that you drew, You're going to estimate the coordinates, so you're going to estimate what each point is, and then keep in mind these do not have to be original data points. So we're not using original data points, we're using 2 points on the line you drew. And using those 2 points, we're going to write an equation of the line. So let's look at example 3. The data gives the systolic blood pressure Y of patients X years old. Approximate the best fitting line for the data. So first we have to graph this. So to graph it, looking at our values, our X values go all the way up to 70. Our Y values go all the way up to 152. So we want to make sure we label our X and Y appropriately for this. I'm going to go ahead and draw these in here. So if I need to go up to 70 on the x-axis, I think we're going to have to go by tens. 10, 20, 30, 40, 50, 60, 70. Now, keep in mind, if I don't like that, if there's a different value I'd rather use, I can redo it. I don't have to keep that. So counting here, I figured out I could go by fives. And I would get to 70. So that works as well. For the Y's, we need to get up to 152. So for that, let's see. We're going to have to go by more than tens. If I go by 15s, I should get far enough. So I'm going to do 15, 30, 45, 60, 75, 90, and then we have 105. And then after 105 is 120. After 120 is 135. And then we have 150, and then 165. Okay. So now that I have my X and Y axis labeled, I'm going to go ahead and plot those points. So for the first point, 43, 128, I go over to approximately 43 and up to approximately 128. And then I'm going to do 48, 120. And then 56, 135. And then 61, 143. 67, 141. And then 70 is 152. Okay, so here are all my points. So now I need to make a best fitting line. So to do that, I'm going to draw a line in the same direction as my points. Now keep in mind it does not have to go through all the points. So I am going to do the best I can to draw a line so that I have as many above as I have below. Now from here, you would pick 2 points on this line to create your equation. So I don't think I like this line very much. I'm going to go ahead and fix it. And that's the great thing about this is you can adjust it if you want to. I want to make it look a little bit better. Okay. So I'm going to use 2 points that are on pretty numbers. So here I'm going to use this point on this line that's 40, 120. And I'm also going to use 60, I'd say that's 140. So those are the points on my line that I'm going to use to write an equation. So first, to write the equation, I need to find the slope. So to find the slope, I want to write the slope formula first. And the slope formula is m equals y2 minus y1 over x2 minus x1. So I have 140 minus 120 over 60 minus 40. So my slope is 20 over 20, which is 1. From there, I'm going to use one of my original points and the slope to write an equation of a line in point slope form, which we've done in previous sections. So I'm going to use the 40, 120 as my x1 and y1. So y minus 120 equals 1 times x minus 40. And then from there, you would want to distribute the 1 to get x minus 40 equals y minus 120. And then we add that 120 to both sides. So my final answer, which I'm going to put over here, is y equals x plus 80. And that's it for that problem. In the last example, it says use the equation from the line of fit in example 3 to predict the systolic blood pressure of a patient that's 75. So you'd want to use that equation you just wrote, y equals x plus 80. And we're using 75 for our x, that's the age. So y equals 75 plus 80. So 155 would be the systolic blood pressure. Now that's it for today's notes. If you have any questions, be sure to contact your teacher.